We're going to go over Coulomb's law. Before I start discussing what Coulomb's law is, there are a few constants that I need to give you so you can understand the equation. The first is K. K is equal to 9 times 10 to the ninth newtons meters squared per Coulomb squared. We haven't gone over coulombs yet. Coulombs is the unit for charge. The next constant we need to go over is sigma naught, which is the permittivity of free space. Sigma naught is equal to 8.85 times 10 to the negative 12 Coulomb squared newtons per meter squared. These two constants are related by the equation K is equal to 1 over 4 pi sigma naught. Now that we have all of the equations that we need, or all of the constants that we need, I can give you the equation for Coulomb's law. This equation is force is equal to K times the charge of object 1 times the charge of object 2 over the distance between the two objects squared equals to the force. So let's explain this in an example. You have two objects, 2 points. Object 1, which we're going to call Q1, charge 1, and object 2, which we're going to call Q2, charge 2. These two objects are 1 meter apart. And both have charges of 1 Coulomb. Now we have all the required information to apply Coulomb's law. We use the formula. We say force is equal to K, 9 times 10 to the ninth newtons times meters squared per Coulomb squared times the charges together, 1 Coulomb, 1 Coulomb, over r squared, which is the distance between the two, which we know to be 1 meter, and we square that. So we end up with 9 times 10 to the ninth newtons is the force. But what does this force represent? This force represents the Newton force on each of the objects individually. So the force on Q2 due to Q1 is this. So there's going to be a force equal to 9 times 10 to the ninth newtons on Q2 going in this direction. And there's going to be a force of 9 times 10 to the ninth newtons going in this direction on Q1. The one difficult thing that you're going to have to figure out is how to tell which way the arrow is pointing. You have to ask yourself, is the arrow pointing this way or this way? And this is how you tell. I mentioned in the previous video that opposites attract and likes repel. So, if these two are different, if one is -1 Coulomb, the other is 1 Coulomb, then they're going to attract, and both are going to be focused towards each other. But if they have the same sign charge, if it's either both 1 Coulomb or both -1 Coulombs, they're going to repel, and they're going to go in this direction.